Now we're going to consider how the Fed or any other central bank can control the amount of money in the economy, can control the money supply. So first of all, what is the Fed? Well, the Fed, more formally the Federal Reserve, is an organization that's given responsibility by the Congress, set up by the Congress in 1913, and its purpose to control the money supply in broad terms. In fact, Article 1, Section 8 of the Constitution gives Congress this authority. Congress has the power to coin money and regulate the value thereof. The Congress has designated the Fed as the agency to carry out this job through the Federal Reserve Act of 1913, which is still it's still the rule of the land after a few amendments. Currently, the Fed has a structure. There's a board of governors appointed by the President of the United States. There's 7 of them. They have to be confirmed by Congress. But it's broader than that. There's also people who participate in the Federal Reserve System that are not appointed by Congress. They're located in the district banks around the country, Dallas, San Francisco, New York, Cleveland, Chicago, etc. There's 12 of them. And they're presidents of these district banks serve on something called the Federal Open Market Committee, FOMC, along with the governors appointed by the President, confirmed by the Congress. So it's an unusual structure. It represents some balance of power in the country of the executive branch in Washington and the Congress in Washington, but also spread around the country through the district banks. Of course, there's a lot of other central banks around the world. Let's just consider that for a minute. Here's an example of 6 central banks. You have the European Central Bank, which is actually a central bank for many different countries in Europe together. France, Germany, Italy, Greece are part of the European Central Bank. And they have the same monetary policy, the same money. Their money is called the euro for all those countries now. So they have one central bank for those countries. Mario Draghi in the picture is the president of the European Central Bank. Draghi is an Italian. Then you have the Bank of England. That's currently now run by Mark Carney. Over on the right, he replaced Mervyn King. If you look down further, you can recognize Mark Carney was the governor, the head of the Bank of Canada. He's now been recruited by the British to run their central bank. In Japan is a recent appointment. The man on the left, Shikawa, was replaced by the man on the right, Kuroda, because the government wanted more money, actually. Wanted to say more money, Kuroda, and Kuroda's in charge of doing that. In all these examples, you can see there's a fair amount of turnover from one central bank to another over time. That's just a 2-year span. Over on the right, you have at the top Bernanke, who was the chairman of the Federal Reserve. His term expires in January 2013, and his replacement has been nominated by President Obama as Janet Yellen. She'll be the first woman to head the Federal Reserve, and you can see it's rather unusual to have women in charge of a central bank at this time. Maybe the signs of good times in the future. Now let's consider sometimes central banks get created. This is an example I would call the birth of a central bank. After Saddam Hussein was thrown out of power in Iraq, a new central bank had to be set up where its job was to create money. Under Saddam Hussein, it was mainly a vehicle to give loans to cronies and favorites. So a new central bank had to be set up. This is the first meeting of that central bank. So central banks are all over the place in different countries in different ways. So now let's consider how the Fed, same thing as other central banks, actually controls the money supply. So first imagine if all money were currency, you didn't have deposits as part of the money supply, then the Fed could simply print all the currency and the total amount of money would be easily determined. So it's pretty straightforward if there's only currency out there. The Fed can decide how much there is. That's its job as designated by Congress. But this is not the real world because deposits are a major part of the money supply. As we've already noted, the money supply is currency plus the deposits that people like you or me hold at banks. So what happens then? Well, in order to control the money supply, therefore, the Fed must somehow have a link to the deposits at banks. And that might seem pretty hard because the Fed can't tell me how much money to put in the bank, can't tell you how much money to put in the bank. But it somehow has to be able to control the sum of all our deposits at banks if it's going to control the money supply and prevent inflation from picking up. So let's see how this works. Let's introduce some symbols. Let's say the money supply is represented by M again, currency by CU, and deposits by D. So then we know that M is equal to CU plus D by definition. Banks usually hold bank reserves close to a fraction of their deposits. And that's going to be the key for figuring out the way in which a Fed controls the amount of deposits, because the Fed can control the amount of bank reserves. So the link we're looking for is from these bank reserves to deposits. So what are bank reserves? Bank reserves are simply the deposits that a bank, like Wells Fargo, for example, holds at the central bank, holds at the Fed. Just like you and I have deposits at our local bank, perhaps Wells Fargo, then Wells Fargo has deposits at the Fed. The deposits of that bank at the central bank, deposits of Wells Fargo at the Fed, those are bank reserves. It's a technical word for their bank reserves. Now, there's an equation that represents the fact that there may be a requirement that their bank reserves are a certain fraction of the deposits, or it may be a custom that the banks have to hold bank reserves as a certain fraction of the deposits. The ratio of bank reserves to deposits is sometimes called the reserve ratio, symbolized by little r. For example, if r equals 0.1, then bank reserves equal 0.1 times deposits, or in words, bank reserves are equal to 10% of deposits. The reason why banks hold reserves or are required to hold reserves is they want to be sure they have some funds to pay out in case depositors come and want some money. Wants to get, I'd like my money back out of the bank. Bank has to be ready to pay it with something, and those reserves are there for that purpose. Note that if you have bank reserves as a fraction of deposits, say like 0.1, then you can see that deposits, which we're after the ability to control, is 1 over r times bank reserves. If r is 0.1, then deposits are 10 times bank reserve. So that's the link we're looking for. If the Fed could control the amount of bank reserves, the amount of deposits that the central banks hold, the amount of deposits that the commercial banks hold at the Fed, then it should be able to control deposits that you and I hold at the Fed, or some with everyone else. So in fact, the Fed can also control bank reserves. And this is the key, really. It's the key step. How can it control bank reserves? Well, whenever it buys something, it has to pay for it with something. So if it buys government bonds, it has to pay for those government bonds. And how does it pay for those government bonds? It credits, say, Wells Fargo or some other bank with deposits at itself. It says, okay, we'll get $10 million of government bonds from you. We're going to take that, but we're going to give you $10 million of deposits on our balance sheet. That's your money. That's your $10 billion. You can do what you want with it. It's a form of payment. And similarly, if it sells, it goes in the reverse direction, and it would draw down the deposits if you sold the bonds back to Wells Fargo or some other bank. So the idea is by buying and selling things and paying for them and getting paid with reserves, these deposits at the Fed can actually determine the total amount of reserves. And there's lots of things in principle the Fed could buy. It's mainly buying government bonds. But I always argue, hey, it could buy anything, literally. And the example is ketchup. The Fed went out and wanted to buy more ketchup. It could pay for that ketchup by increasing bank reserves, crediting banks with deposits on itself. So the general idea is by buying and selling government bonds, the Fed can control the amount of bank reserves. And those actions, those buying and selling actions, are called open market operations because the Fed is buying almost always some kind of bonds, usually government bonds. As we can see, there's times it buys other things, not ketchup, but it buys other things, and those are called open market operations because it buys them on the open market. So now let's see how this thing works, how this idea works, that by changing the amount of reserves, the Fed control the deposits. And we already know the answer because we know that if the deposit ratio is R, then the amount of deposits is 1 over R times the amount of bank reserves. But let's see how it actually works and how it plays out in practice. We need to look at a balance sheet of a bank to do this. Balance sheets, of course, have the assets on the left-hand side, liabilities on the right-hand side. For this typical bank, Bank 1, let's assume its deposits as a liability, of course, is 100. And its assets, let's think of 3 different things. It makes loans to people or businesses. It holds bonds. It may hold government bonds, may U.S. Treasuries, and it holds these reserves. Those are the deposits at the Fed. So if there's a change in deposits or loans or bonds and reserves, you always have to have the left-hand side summing to the right-hand side. Assets have to equal liabilities, and of course, in this example, 100 equals 100. Now let's consider the Fed taking an action, an open market purchase. Suppose it buys 20, let's say $1 million from Bank One and pays for it by increasing reserves by 10. So just to repeat it again, this is going to be a case where bonds are going to go down by 10 and reserves are going to go up by 10. There it is. So again, the Fed has purchased $10 billion of bonds from Bank One and paid for them by increasing reserves. Now what's going to happen? Well, if you look at this balance sheet, you can see that the bank is holding 20 in reserves and deposits are 100. That's a reserve ratio of 0.2 or 20%. They don't need to hold that many reserves. So what's likely to happen is they'll try to loan out some of those reserves, try to make a little money, make a loan to a business, maybe or make a loan to a consumer, buying a house or something like that. So the next thing that's going to happen is reserves are going to go down. There they go. In this case, loans went up by that $10 billion. So this bank, Bank One, now is in pretty good shape. It's got its reserve ratio at 10%. It's got loans equal to 70, so it's making some more money as a result of this. And that's really the first step in this process. But it's not the last step, because the person who got that extra $10 million in loans is going to deposit it somewhere, going to deposit that some money somewhere, and let's suppose it deposits it at Bank Two. Okay? So the first builder has the $10 billion in loans, $10 million in loans deposited at Bank Two, and Bank Two is going to say, hey, I can loan out some of that 10 because I only need to keep 1 in reserves. So it loans out 9 and keeps 1 in reserves. The firm that got that 9 in new loans is going to deposit it at some other bank. Suppose that 9 in loans is deposited at Bank 3. Well, Bank 3 is going to make the same calculation. It only has to keep 10% of the 9 increase in deposits, and so it'll keep 90 cents and loan out 8.1, and so on. So deposits actually are increasing from 10 and then 9 and then 8.1, etc. You can see, and it really is just the sum of the product of 10 times 1 plus 0.9 plus 0.9 squared plus 0.9 cubed, etc. And when you sum up this kind of a series, it's the same as dividing by 1 minus 0.9 or 0.1. So you're taking 1 divided by 0.9 or 100. And that's really what plays out. And you can see in this example, you get pretty close to the 100 after just a few steps. Now the bottom line, of course, is that the increase in deposits has been 10 times the increase in reserves. In this particular case, remember, reserves went up by 10, so delta R was 10. The deposits have gone up by 100, so delta D is 100. And of course, 100 is 10 times 10. So in a way, we didn't need to look through the gory details of this deposit expansion. We could figure that out just by the logic or the arithmetic of this. But it's also helpful to understand how it actually plays out in practice. So let's summarize what we've got here. With the money supply, we've defined it as money plus currency plus deposits. And the Fed, therefore, can control the amount of the money supply in the economy by controlling the sum of the supply of currency, CU, and the supply of bank reserves, BR, because the bank reserves gives a certain amount of deposits. 1 over R times BR equals demand deposits. And this will occur as long as banks keep to that ratio R. If it's 0.1, this is going to work quite well. The Fed can increase bank reserves by 10, as in this example. And if the reserve ratio is 0.1, deposits will increase by 100. That's generally how it is supposed to work. Now, sometimes the ratio changes, and in fact, there's been big changes in the ratio in recent years, and it's made monetary policy both more difficult and more interesting. And I want to conclude this discussion with some data to illustrate this. This is a picture of bank reserves. We know what they are now. Those are the deposits of the banks at the Fed. And you can see it's pretty stable until the financial crisis in late 2008. And then it's gone up and up and up. That represents actions that the Fed has taken to buy securities, to buy government bonds, also to buy some kinds of mortgages as well. It's buying a lot of things. And it's paying for that with these bank reserves, these deposits of banks at the Fed. And it's risen by quite a bit on the vertical axis. You can see that's billions of dollars. So it's gone from under 100 billion to over 2,000 billion in this period of time. Now, if the reserve ratio was a constant, we would see an equal kind of increase in deposits. Well, here's a picture of deposits. So until 2008, that ratio is pretty steady. And you can see it's not much movement, at least compared to what's happened recently. With the explosion of bank reserves, you see demand deposits have increased. That's what this theory would be telling you. But they've not increased by the same percentage by any means. And so this reserve ratio has been changing, therefore. The direction of movement is the same as predicted. Demand deposits have increased, but not by as much as bank reserves. So we want to explore what actually happens in monetary policy in more detail to see why bank reserve ratios change. But nonetheless, the basic theory of how the Fed or a central bank can control the money supply is clear from the deposit expansion ratio, the notion that banks hold at least some fraction of their demand deposits as reserves, and that creates this causal mechanism that enables the bank, the Federal Reserve, the central bank, to control the amount of money in the economy. Thank you.